Okay, here is the rest of the review. Last two pages we're doing. I got a cookie. I'm going to be eating cookies today. Guillermo has started a coin collection. He hopes to double the number of coins he has in collection every year. He has 4 coins, starting with 4, and we're doubling. So, write a sequence that represents the number of coins he wants to have in his collection each year. You must show a minimum of 4 terms. We don't even have to write the equation here or the rule, the function. We're just going to write the term. So he starts with 4 and he doubles. Goes to 8. Double 8, you get 16. Double 16, you get 32. Okay? What is the common ratio? How do I get from 4 to 8? How do I get from 8 to 16? It's doubles, it's 2. So the common ratio is 2. Does this sequence represent growth or decay? It represents exponential growth because we just don't want to say because the numbers are going up. We want to talk about the common ratio because the common ratio is greater than 1. Remember that common ratio, if it was greater than 1, it says growth. If it was a fraction less than 1, it was decay. Okay. 17. Use the following information for both A and B. 6 stray cats. We're starting with 6 cats. That's our initial value. Part A says the cats double. I'm going to underline that doubles. Circle. My A is my initial value, which is 6. My B is the part I underline, which is that common ratio. The B value, which is 2. It says state the exponential function. So y equals A times B to the x. So A is 6 times 2x times 2 to the x power. So that's my exponential function. Now it asks how many cats will there be in 2 years. We want to go back up here. It says these cats double every 4 months right here, and this is years. So I have to take 2 years. How many months are in 2 years? There's 24 months in 2 years, and I'm going to divide that by the 4, okay? And that's how I'm going to get 6. That's what I'm going to plug into this form. Y equals 6 times 2 to the 6th power. I got the 6 because in 2 years there are 6 4-month periods in 2 years. We can write them out, or we can convert the years to the months and divide by the number of months. So 24 divided by 4 is 6. I can go right to my calculator. I can turn there, you can see it. I'm going to plug this in. I'm going to say 6 times 2 to the 6th power. 384. Let's see. So that equals 384. What are we talking about? Cats. Okay. Part B. I still start with 6 cats. A is 6. My B value, cats triple every 4 months. So they triple. B value is going to be 3. My exponential is going to be the initial value, which is 6, times the B value, which is 3, to the x power. So y equals 6 times 3 to the x power. How many cats will there be after 2 years? Once again, 2 years is going to be 24 months. Right? Whoops. 24 months, and I'm going to divide that 24 months by 4, which is going to equal my 6. So y equals 6 times 3 to the 6th power. We're going to go back to our calculator and say 6 times 3 to the 6th power. That's a lot of cats. 4,374 cats. So exponential growth, you can see if it doubles, you get a bunch of cats. If it triples, same time frame, start with the same amount, a lot more cats, 4,374. Okay, state the exponential function for the table listed below. So this is where we are going to just find the pattern. X's are going up by 1. What's happening here? Fractions. I don't know if I want to deal. Let's look at 2 to 3. How do I get from 2 to 3? Well, I can multiply by 3. Does that work here? 6 times 3 is 18. Does it work back here? 2/3 times 3, if we put it in the calculator, is 2. And 2/9 times 3, which is 6/9, which reduces to 2/3. So my B value is 3. My A value, remember when we have that table, we circle that value where x is 0, and that's the A value. So my function here is going to be y equals 2 times 3 to the x power. Okay. Part B, exponential. How do we get? On this reviews for my class, these numbers are wrong. This number has to be 14. This is 28. I believe other teachers have the correct review. If not, it'll work out better if these are the numbers. So how do I get from 7 to 14? Multiply by 2. 14 to 28, multiply by 2. Does it work back here? Well, 7/4 times 2 is 14 over 4, which is 7/2. 7/2 times 2 is going to be, the 2's are going to cancel, going to give me 7. So my B value is 2. My A value, right there in the middle, that's 7. My function, y equals 7 times 2 to the x power. Okay. 19, graph the following functions. Let's not make it harder than it is. Let's put it right into the calculator. So 3 to the x plus 2, and then we have to arrow over minus 6. If you have a TI-83, you have to put parentheses around here. And we can take a quick peek at the graph if we wanted to. Looks like it's going to be exponential growth, which makes sense. We're going to take a look at the table because it says graph. We need a table. And I'm going to use, I think, let's see, -3, -2. So I'm going to say my XY table. -3 is 5.7. -2 is -5. -1. -3. That's a -1. 0 is 3. 1, I'm way up at 21, so this should be enough. So at 0, I'm at 3. At -1, I'm at -3, way down here. At -2, I'm at -5. At -3, I'm at -5.7. We can kind of take a look at the calculator. It's going to get closer and closer to -6, but never touch -6. So it comes along -6, goes through and explodes. Exponential growth. Grows really fast, never ever crosses -6. Same thing for this one. I'm going to make my XY table right here. We are going to go to y equals, clear out what we have in there. I'm going to put 4 to the, let's clear that out, 4 to the x minus 3, scroll over, plus 1. I'm going to look at the graph real fast. Looks like it's growth. Okay, makes sense it'd be growth. Let's look at the table. So you see how this table, all the negatives go really close to 1. So let's start with 1, 2, 3, 4. How about that? So at 1, I'm at 1.06. At 2, I'm at 1.25. At 3, I'm at 2. At 4, I'm at 5. Okay, we know it gets closer and closer to +1. Okay, the calculator says it touches 1, but that's because of the rounding error. So, never going to cross +1. So, at 1, I am at 1.06. At 2, I'm at 1.25. At 3, I'm at 2. At 4, I'm at 5. So it looks like it never crosses 1, comes up, goes on forever that way, goes on and gets really close to 1 but never crosses it. So that would be the graph for that. Okay,